Section 10.2 is on simplifying radical expressions. A radical expression is simplified if no radicands have perfect square factors other than 1. That is, underneath the radical sign, you don't have any perfect square factors. If no radicands contain fractions, and if no radicals appear in the denominator of a fraction. Here's a couple properties that apply to square roots. We can say that the square root of the product a times b is equal to the square root of a times the square root of b. Or in other words, looking at this with numbers, if I have the square root of 6, I can break that down into the square root of 2 times the square root of 3. Same thing also applies for division. The square root of a divided by b is equal to the square root of a divided by the square root of b. Putting some numbers in there, the square root of 7/8 is equal to the square root of 7 over the square root of 8. Let's take a look at a couple examples on how to simplify different types of radical expressions. Directions say simplify each expression. Number 1 is the square root of 54. Probably the easiest way to do this is to do a factor tree. Let's break it down into all of its factors. So the first thing that comes to mind is 6 and 9. And 6 will break down into 2 and 3, and 9 breaks down into 3 and 3. And remember, all of the numbers that are at the ends here are the numbers that multiply to 54. So 2 times 3 times 3 times 3 equals 54. So that means I can write the square root of 54 as the square root of 2 times 3 times 3 times 3. Now, looking at the 2 and the 3 and the 3 and the 3, if I can buddy any of those up, like these 2 3's here, those can come outside the square root sign. The 2 and the 6 don't have any, the 2 and the 3 don't have anybody to buddy up with, so those stay as a 6. So simplified, the square root of 54 is 3 square root of 6. Another way to take a look at this problem is if you can recognize perfect square factors. Let's take a look at this again. So 54 is 6 times 9. So that means that's the square root of 6 times the square root of 9. And I actually stopped there because I recognized that 9 was a perfect square. The square root of 9 is 3. Square root of 6 can't be simplified any further, so that's 3 square root of 6. So it's actually two different ways you can do a problem. You can break it down, factor tree, to get down to all of the prime factors, buddy them up, bring them outside. Or if you can recognize that the number has a perfect square factor, just take the square root of that. Here's another example. The square root of 6 times the square root of 8. Actually, a couple different ways you could do this. You could multiply the 6 times the 8 and do the square root of 48. Or I'm just going to break these down into their factors. So the square root of 6 times the square root of 8 is actually 2 times 2 times 2 times 2, because I had 4 2's here. And remember, I'm just looking at the numbers that are hanging off at the end. And a 3. Using the buddy up method, these two guys buddy up and can become a 2 outside. These two buddy up and can become a 2 outside. 3 doesn't have a buddy, so he has to stay under the radical. Or 4 square root of 3. Again, I could have noticed that the square root of 4 here would turn into a 2, and that I actually could put these two 2's together and make another 2, and that would give me my 4. Here's a little bit bigger one. Square root of 32, a squared, b to the 4th, c to the 5th. Probably the easiest way to do this is, let's go ahead and factor tree this and come up with all of my prime factors, which actually ends up being 5 2's. So this is the square root of 2 times 2 times 2 times 2 times 2. And I have 2 a's, and I have 4 b's, and I have 5 c's. Okay. So there's a complete prime factorization of my expression. Now I'm going to buddy them up and bring them out front. There's a 2. There's another 2. There's an A. There's 2 B's. And 2 C's. Each one of those pairs becomes a C out front. And then what I'm left with underneath is I have a 2 and a C. Cleaning that up a little bit, that's going to be 4A B squared C squared square root of 2C. But there is one additional thing that I need to do, and that is put absolute value bars around this A, because the rule says that we're going to use the absolute value bars when the exponent inside the radical is even, but then when you simplify that and the exponent outside is odd, you need to put bars around that. So use absolute value bars when the exponent inside is even and the exponent outside is odd. So taking the square root of an even power and getting an odd power, you need to put bars around it. Now there is a little bit simpler way to do this. Instead of writing out all of these prime factors, I could think of 32, and that's actually going to turn into 4 square root of 2. And then looking at a squared, the square root of a squared is just a. The square root of b to the 4th, just take that 4 and divide it by 2. That's going to give me a b squared. And then c to the 5th, taking the square root of that is going to give me a c squared with a square root of c left over. Okay, put the stuff under the square root together. And then out front I'll have my 4 and my a, which has to be in absolute value bars, b squared, c squared. So a couple different ways to do it. If you can see the patterns in the numbers, go ahead and do it this way. If it helps to write out all of the factors, go ahead and do it that way. Example number 4, the square root of 3a over 8. Remember, I can break that up and say that that's the square root of 3a over the square root of 8. And since I've already seen it before, I know I can simplify 8. This is going to turn into a square root of 2. I'm sorry, a 2 out front with a square root of 2. So the square root of 3a over 2 square root of 2. But remember, one of my rules on whether or not a radical expression is simplified is that I can have no square roots, no radicals in the denominator. So I cannot have this square root of 2 in the bottom. So what I need to do is called rationalizing the denominator. I need to rationalize the denominator. Square root of 2 is an irrational number, and I need to make it a rational number. To do that, I'm going to multiply it by 1. And the way I'm going to write 1 is square root of 2 over square root of 2. Square root of 2 over square root of 2 is 1, so by multiplying by 1, I'm not changing the problem. But what's going to happen is when I multiply these two square roots of 2, that's going to give me just a 2. So across the top, that's going to give me the square root of 6a, because square root of 3 times square root of 2 is square root of 6. On the bottom, I have my original 2, and then square root of 2 times square root of 2 gives me another 2, or cleaning that up, 6a over 4. And that's my final answer. I no longer have a radical in the denominator, and that's as simplified as it gets. Now, do not try to cancel that 6 and that 4, because you cannot cancel something that's underneath a radical with something that's not. And my last example here also has a square root in the denominator, but notice that this time it's a square root of 7 being subtracted from a 3. In other words, it's not just a plain old square root of 7 in the denominator. What I need to do here is to multiply by the conjugate. And the conjugate is going to be the same numbers, but with a different sign in between them. So in this case, it's going to be 3 plus a square root of 7. So I'm going to multiply my problem by 3 plus a square root of 7 over 3 plus a square root of 7. Notice my original problem had a minus. This one's going to have a plus. Now what this is going to do is it's going to act like multiplying something like x plus 2 times x minus 2. We'll see what happens here. So on the top, I'll be distributing. And on the bottom, I'll be foiling. Okay, so let's go ahead and distribute on the top and see what we get. That's going to give me 21 plus, and 7 times the square root of 7 is just 7 square root of 7. Now on the bottom, let's FOIL. First is going to give me a 9. Outer is going to give me a positive 3 square root of 7. Inner is going to give me a negative 3 square root of 7. And last, it's a little tricky, negative square root of 7 times a positive square root of 7 is going to give me a negative 7. Now, notice what's going on right here. These are going to cancel each other out. So I'm left with 21 plus 7 square root of 7 over 9 minus 7, or 21 plus the square root of, plus 7 square root of 7 all over 2. Okay, now a couple things about this. If this were like a 22, you could not cancel those. You'd have to be able to cancel both whatever number is here and whatever number is in front of the square root with the 2. Also notice you cannot add the 21 and the 7 to get 28. So this right here is my final answer. So to simplify a radical expression, make sure that there are no perfect square factors underneath the square root sign. Make sure that you have no radicals in the denominator, and that everything is simplified or canceled as much as possible.